Okay, so what we're going to look at here is exponents. Now, you may have seen this before, but we just want to kind of go over some of the ideas with a positive exponent, exponent of 1, exponent of 0, negative exponents. That way we have an idea of what to expect later on when we get into polynomials and how to work with those, okay? So if you notice this guy here, this whole thing we would consider to be a power, okay, even though normally we would just say exponent, but really it's the power. And then the 2 is the actual exponent, okay, and 5 is the base, okay. Now what this really means here is the exponent tells us how many times the base is being multiplied, essentially how many factors there are of that base being multiplied. For instance, here we see that there are 2 factors, okay, 2 factors essentially, because we have 2 5s being multiplied. Hence, that's what this number 2 is saying. We're taking the base and we multiply 5 times 5. There's 2 5s there. And then if we evaluate that or simplify that, 5 times 5, we're going to get 25, okay, and that would be our solution. Now, sometimes when we're working through these later on with the product rule, quotient rule, and things like that, you might only have to simplify it into a positive exponent, okay, and your answer might look like something like 5 squared, and we'll see that later on. Or they might actually want you to evaluate it and what is the actual numerical value. In this case, 5 squared is 25, okay. Now, what we're really saying is when we're talking about positive exponents, this guy right here would be 4, a base of 4, raised to an exponent of 3, okay? So it would be 4 to the 3rd power, or you might say 4 cubed, okay? And what that means is we're going to have 3 of these 4s here being multiplied, okay? Then, of course, in a calculator, what you could do is hit 4 times 4 times 4. That's one way to do it, and we get 64. Or another way you might see it in your calculator is you would type the number 4, and over on the right-hand side, there's a symbol that looks like this. And if you click on that, that's going to allow you to enter in an exponent. And then you type the number 3, 4 raised to that power, hit enter, and you get 64 that way as well. Okay, so that's just one way we could do a positive exponent. Okay, then of course, same thing there. You have 7 to the 4th power, okay, which we would get 2,401. Then here we have 9 to the 5th power, which means 9 times 9 times 9 times 9 times 9. So we have 5 of these factors of 9. That's our base here. And then if we multiply that in our calculator, we get 59,049. Okay. So, and it's asking us what we would say. We'd say 9 to the power of 5, okay? And of course, you could go through these examples too. We could do a couple more here. So when I have a base of 11 raised to an exponent of 2, we're going to have 2 of those factors 11 being multiplied. That's what that number 2 means, okay? So we have 2 factors, and then 11 times 11 in your calculator, we get 121, okay? And I'm not too worried about this part right now. Let's try one more. So if I have 5 to the 6th power, that means I'm going to have 6 of these 5s being multiplied, okay? Kind of running out a little bit of space, but we have 6 of these factors. And so we would take 5 times 5 times 5 times 5 times 5 times 5, or you could just put in your calculator 5 raised to the 6th power, and we get 15,625. Okay, so that would be our solution. Now, I also want to talk about what happens when we have a fraction and a decimal. Okay, so if we have a fraction, it's still the same principle. We're taking the base of 1/2 and multiplying it by itself here 5 times. Okay, so then I would multiply, when we're multiplying with fractions, we multiply the top together. So it'd be 1 times 1 times 1 times 1 times 1, which is still 1. Then 2 times 2 times 2 times 2 times 2, we'd have 2 essentially raised to the 5th power because we're multiplying it 5 times, and we get 32, okay? Same thing when we're dealing with a decimal. This guy over here is telling us that we have 0.2 times 0.2 times 0.2, okay? So multiplying that out in your calculator, okay, we should get 0.008, okay? And of course, you could also raise it to the third power and we'd get to the same thing, but we get 0.008, okay? Then that's dealing with the positive exponents. The next thing we want to look at also has to deal with raising things to a power of 1, a power of 0, and then here in a little bit to the negative exponent. Now raising to a power of 1 and a power of 0 is really not that too difficult here, okay? Anything, no matter what it is, raised to a power of 1 is going to be that same thing back. For instance, 5 to the first power is still 5, okay? We have one factor of 5, okay? Anything to the 0 power, this is just the rule here, is always 1. For instance, 5 to the 0 power is 1. So anything to the 0 power is 1, okay? So looking at this guy here, negative 3 to the first power would be negative 3. 17 to the first power would be 17. 12 to the 0 power would be 1. And then again, anything to the 0 power is 1, okay? Now the last thing we want to look at here is dealing with negative exponents. And with a negative exponent, the way to think of it is whether it's on the top or whether it's on the bottom. Wherever the negative exponent is, you're going to flip the fraction, essentially, and then change the exponent so that it's positive, okay? So this guy right here, if we were to flip it, a over n would go to the top, 1 would go to the bottom, although you really don't need to write the 1. So things are going to flip, and the negative becomes a positive. Or another way to look at it, starting here, if we flip this guy, we could write it over 1. If this started at, well, I should put the negative there. If we started with a negative exponent, we would put it over 1, flip it, and we get 1 over n, or a raised to the nth power, okay? Now, the negative exponent, when we flip it, becomes a positive. So let's just look at some examples here of what we're talking about. 10 to the negative third, we could treat that like it's over 1. Okay, since we have a negative exponent, we're going to flip it, and it becomes 1 over 10 raised to the third power. But now that power is going to be positive. Okay? Same thing here. We have 2 to the negative fourth. So if we're going to write it with a positive exponent, we could treat it like it's over 1, flip it, and we'd have 1 over 2 to the fourth power. Excuse me. But now the exponent is going to be positive, okay? Now, if it starts at the bottom, it's still the same principle. You're still going to flip it, but it's going to move from the bottom to the top, or from the denominator to the numerator. So if we flip this guy, we'd have 3 to the 7th power over 1. And of course, you don't really have to write it over 1, so it would be 3 to the 7th power. Try that again. There we go. Okay, so we'd have 3 to the 7th power, and now our exponent is positive. So again here, flipping it to the top, we'd have 5 to the 9th power over 1, or we could just simply say 5 to the 9th power. Okay, now of course on both of these you could simplify it in your calculator. If you took 3 raised to the 7th power, you would get 2,187. And in your calculator, if we multiply 5 9 times, or 5 raised to the 9th power, we would get 195,000. Oh, nope. Back it up here. Let's just write it all out first before we read it off. There we go. So, sorry, 1,953,125. So that's what our solution would be. 1,953,125. Okay. Then this last one here, it still applies when we're talking about decimals and fractions as well. What we're going to do is we're going to take our fraction again, and it's going to flip, but now we're raised with a positive exponent, okay? Now, it seems kind of odd because it was at the top originally, but it's not really associated with either one of these. What's really happening here is both of those guys have that exponent, okay? So when we have this parentheses here, it's saying both of those guys have that -2 exponent. So what we're really doing is flipping the fraction, but now they both have a +2 as their exponent. So what this means is now we can treat this like we did above. Our base is 9/7, and we're going to multiply it by itself twice. Okay, or you could just plug it in as 9/7 raised to the second power in your calculator. Okay, now the way you would do that is you would plug it in terms of parentheses, then you put 9 divided by, okay, the division button, 7, okay, and then you would close the parentheses, raise it with that caret to the second power, and then you'd be able to determine what the solution is going to be, okay? So that's one way that you could approach it, or you could just multiply it out here. It'd be 9 times 9, which is 81, and then 7 times 7, which is 49. And I believe if you're going out in the calculator, let's just try this out. We have 9 divided by 7 in the calculator raised to the second power. Yeah, it's going to give you a decimal form, but it's still the same idea. If you take 81 divided by 49, you're still going to get the same answer, okay? So this would be our solution.